Welcome to the Physics Academy. Now we are going to the study of the quantum mechanics. This one is the first question of the quantum mechanics. Question number 34, set number 8. The wave function of a system is given by a e to the power ikr into r upon r naught. Okay, and where a and r naught are constant, are given constant. The probability current density for this at r is equal to r naught is equal to how much? Okay. We know that. How to find out the current density? J is equal to yes h cross upon 2mi okay, into psi star del psi minus psi del psi star. Okay, this is the formula for finding the current density. Okay, now our given wave function psi is equal to yes psi is equal to a e to the power ikr into r upon r naught. They are given this wave function. Now we need to hear psi as well as psi star. Okay, this is the psi. Here function is imaginary, then sign also change. Okay, then what is the value of psi star? Psi star is equal to a r upon r naught e to the power minus ikr. Why here sign become minus? Because here we can take the complex conjugate. Okay, now this will be psi, this will be psi star. Okay, next we can find out the del psi. Del psi is equal to yes del psi is equal to how much? Del psi, what is the value of psi? Psi is equal to a e to the power ikr r naught upon r and psi star is equal to a. Here we can write down psi star, no problem, r naught upon r e to the power minus ikr. Okay, now we can find the del psi. Yes, psi is equal to this one, then del psi, a constant take common out, r naught also constant take common out. Okay, and what is the here numerator r is a variable, denominator r also variable. Suppose we can take the derivative of denominator, then this become minus e to the power ikr upon r square. Yes or no? E to the power ikr upon r square. Okay, 1 by r derivative is minus 1 by r square. Next, second one plus. Second time we consider 1 by r is a constant. 1 by r is a constant, and take the exponential part derivative. This is equal to how much? Ik e to the power ikr. Got it? Now, next. This one is a constant part. Take suppose we can multiply it inside, or we can multiply it by psi. Okay, then psi star into del psi. Okay, what is the value of psi star? Psi star is equal to a r upon r naught. Okay, this one is a star. A into a star mod a square. Got it? Next, here is r naught. Here also r naught square. R naught into r naught square. Next, here is r. Here r square means here this system become minus. Why? Because here is plus sign, here is a minus sign. 1 by r square. R to the power 3. Okay. Next, here e to the power plus ikr. Here e to the power minus ikr. Plus minus get cancelled. First term is over. Second term. What is the second terms? A r naught, and this become a into a star mod a square. Okay. R naught square. Okay. Next, here is r, here also r into r square. Okay, here r square into e to the power minus ikr, e to the power plus ikr get cancelled, and only which part will be survive? Ik part will be survive. E to the power plus minus get cancelled. Means what is the value of a psi star del psi? Psi star del psi is equal to minus mod a square r naught square upon r cube plus mod a square r naught square ik upon r square. Okay, next we can find out the del psi star. Okay, del psi star. Okay, first value is this one. Okay, second one del psi star, a take common out, a star, r naught also we can take common out. Again we can take the 1 by the r derivative is minus e to the power minus ikr upon r square. Got it? This is the derivative with r. Second, at that time we consider this part is a constant. Second time 1 by r is constant. Okay. plus, sorry, minus ik e to the power minus ik r derivative is ik e to the power minus ikr upon r, minus ikr upon r. Okay. Now again here we multiplied by psi into del psi star is equal to, yes, psi a star mod a square epsilon naught r naught square. Okay, here 1 by r, here 1 by r, 1 by r. Okay, next 1 by r, and this is 1 by r square, means here minus 1 upon r cube. Okay, and here is plus minus get cancel, divided by r cube. Got it? Mod a square r naught square upon r to the power 3. Here sign minus, here also getting sign will be minus. Next, second part, a star a means here is minus a star mod a square. Okay. Next, here is r naught, here also r naught square. Here ik as it is, this ik replace here only. Here is a plus ikr minus ikr get cancel upon this 1 by r square. Okay. Now this is the value of psi into del psi star. Here psi star into del psi star. Now we can substitute this value in this equation. Then current density J is equal to, yes, h cross upon 2mi. Okay. Substitute the 1 by 1 value. Okay, first one, psi star del psi is equal to minus mod a square r naught square. Okay, mod a square r naught square upon r cube. Okay, this one is the first term. Second term, mod a square r naught square ik upon what is this value? Mod a square r naught square ik. Okay, ik upon, yes, r square. This is the value of psi star del psi. Next we can substitute the psi del psi star. Okay, this minus become plus. Mod a square r square upon r cube. This will be first term. Here sign is minus become plus. Here minus, second minus plus mod a square r naught square ik upon r square. Okay, now here plus minus get cancel. Then this is equal to how much? J is equal to h cross upon 2mi. Okay, here addition of these two terms. Why? Because both are same components. Okay, then this is equal to how much? 2. This is equal to how much? 2 times mod a square r naught square ik upon r square. Okay, now which part get cancelled? These two get cancelled. Okay, next this I get cancelled. What is the remaining part? J is equal to, yes, h across k mod a square r naught square upon mr square. Okay, but they ask what is the current density at J is equal to, at the J r is equal to how much? R naught. Then this become h cross k upon m into mod a square r naught square upon r naught square. R naught square get cancel. Yes or no? Means what is the simply current density? J is equal to h cross k upon m into mod a square. Which option is correct? Mod a square h cross k upon m. Always memorize this thing. Okay, or we can use the trick also. This is a regular method for finding the current density. Okay, now how do I apply the current density at J value? We need to find this value in any problem. Just to memorize this thing. Okay, here r is a variable. Okay, then psi can be written as psi is equal to a r naught upon r into e to the power I k r into the power I k r. Okay, means except imaginary part, all remaining part consider as a constant. Consider as a constant. Always memorize this thing. Okay, you see here, this is r. R is a variable, but we can apply this trick. Don't consider this one is a variable. This one is a constant. Okay, always memorize. Okay, now here r is a variable, but for applying the trick, we consider this one is a constant. This one is a constant. Got it? Except exponential imaginary part. Okay, means e to the power whatever the imaginary part set on another side, and remaining all part considered as a constant one. How to apply this trick? Simply write down any, they are given any psi value, just write down h cross k upon m, compulsory. H cross k upon m is a compulsory. Okay, next, second one, into amplitude square. Into amplitude square. Always memorize. Whatever we consider the amplitude, write down here it's square only. That's it. But second thing is again important. Here sign is a plus, write down here is a plus. Here sign is minus, at that time write down here is a minus. This is a very simple method. Okay, means no need to do all these things. Directly we can solve in a fraction of second. J is equal to S, J bar is equal to H cross K upon M. This one is compulsory for all problems. Okay, how to decide here? We getting the plus sign or minus sign? Here is a plus. Write down here is a plus. Okay, into amplitude square. Whole term considered as amplitude. Remaining all term considered as amplitude. The squaring of this one. A square R naught square upon R. And just R is replaced by R naught. Then this become. Again we getting same answer, different answer. H cross K upon M into mod A square. Got it? This is the current density for given problem. Got it? We can apply trick simply h cross k upon m into amplitude square. But how to adjust amplitude? Whatever variable or constant, take separate, and we can take the one imaginary part. Okay, except imaginary part, all remaining part consider as the amplitude. Okay, means here r also constant consider. For applying the trick, we getting the answer h is equal to how much? H cross k.